Welcome dear students. So today we are starting linear differential equation, a new kind of differential equation which is neither separable form nor homogeneous type. Okay, now how to identify whether a given differential equation is of linear differential or not. So basically a general form, okay, the general form of linear differential equation will be of this kind. Now what is this P and Q? That's what we are wondering. Here P and Q are constants, okay, so it can be constants or functions of x only. Okay, so you have to observe this line very carefully. P and Q can be constants, okay, or if not constants, they can be the functions of x only. Okay, so such kind of differential equation is known as a first order linear differential equation, because you see the order of the derivative out here is the first order, so that's why this is called first order linear differential equation. Now how to solve this? We'll have a look at the solution later. Now there is one very special thing that you need to calculate from this kind of differential equation, and that is called the integrating factor. We need to calculate this, okay. And what is integrating factor? Integrating factor is given by this particular quantity. Suppose sometimes in case of dy by dx you will be given dx by dy, okay, and in that case what happens is the role of x and y gets changed. So dx by dy plus, remember here we have py, but in this case we have px is equals to q. Now this time the p and q will be the constant, it can be constants or it can be the functions of y that time if it is dx by dy given to us, okay. So you have to be very careful with this particular case. So let's see the first question for the day. Remember this form, okay, we have to express our differential equation in this form, okay. So the first question for the day says dy by dx is 2x cube plus y divided by x. So from here you have dy by dx is equals to, so we can write this as 2x cube by x plus y by x, okay. So if you look at the formula, this is dy by dx, right? So you must have plus py. So where is y? Y is here, so we will take this out there, okay. So when you take this out there, so you get dy by dx minus, can I write this as 1 by, okay, let's not write this as 1 by x, write this as plus minus 1 by x into y. Can I write this way? Obviously, right, when you bring it out here you get minus y by x, okay. But since your form is, let me write the form also, so dy by dx plus py is equals to q. So this is the form. So write plus here, so let me write plus. So p, all of you know it can be function of x, okay. So you see the value p is minus 1 by x is equals to, so how much is left here? So here these two gets cancelled, so here we have 2x square, okay. So here if you compare this with this, here we have p is equals to, p is how much? P is minus 1 by x, and what is q? Q is 2x square, isn't it? So we got the value p and q here, okay. Now what we need to do is we need to find the integrating factor, okay. So integrating factor, alright. So all of you know integrating factor is given by e to the power integral p dx. So let's quickly calculate how much is this, okay. So we have into e to the power p is minus 1 by x, okay, p is minus 1 by x dx. So can I write this as e to the power minus, bring this minus outside, so integral dx by x, can I write this way? Obviously. So this is e to the power minus, how much is this? This is log x. Now can I write this as, see, if you bring this out here, you get log x to the power minus 1, isn't it? This minus, when you bring it inside, you get log x to the power minus 1, which is e to the power log x to the power minus 1 is 1 by x, isn't it? Now there is a formula out here. Now tell me what will be the base out here. Base is going to be e, isn't it? So base is going to be e. Okay, now you must be knowing one formula from logarithm. Okay, that is, suppose if you have a to the power log b to the base a, that means if this matches, then the value of this will be equals to b. This is one of very important formula from logarithm. Okay, if you don't know, you may note down this formula as well. Now see, here this and this, they matches like this only. So that's why the value of this is going to be equal to how much? It is going to be 1 by x. Okay, so by the way, call this as equation number 1. Alright, have you understood this much? Okay then, so if you have understood this much, let's see how to proceed further. Now what we are going to do is, we will multiply equation 1 by the integrating factor, that is 1 by x. Okay, so let me erase this part because I won't have space after that. Okay, so multiplying both sides. Okay, multiplying multiplying 1 by, that is equation 1 by the integrating factor, that is 1 by x, we get, let's see what do we get. So we get 1 by x dy by dx plus, this is going to be minus 1 by x square y. Okay, because 1 by x into 1 by x becomes 1 by x square y is equals to, this becomes 2x, isn't it? 1 by x into 2x square becomes just 2x. Okay, now what you can do here is be very careful, be very careful. Here we have one other term is 1 by x. Okay, so it is 1 by x and into write the other variable y. Now what am I doing? That's what you are wondering, right? So write 1 by x into the variable y. Okay, and differentiate it with respect to x. Okay, now if you go to the rough page and calculate this, you will get this much only. So that's the use of integrating factor. Okay, so when you multiply both sides by integrating factor, you can express the left hand side in the form of u, derivative of u into v. Okay, so this is equals to, we have 2x out here. Okay, now see here carefully. Suppose if you call this as u and if you call this as v, then keep it as it is, 1 by x, differentiate y, so you get dy by dx. Now keep y as it is and differentiate 1 by x, you get minus 1 by x square. Simple. So this can be written as this much. So from here, what you can do is, you bring this dx out here. Okay, so how much do you get here? You get d of, this is y by x, that's what you get, and here you get 2x dx. Okay, now we will integrate both sides. So integrating both sides. So this is the first problem. You may find it difficult, but the next problem, from next problem onwards, so you will find it very easy. So integrate, so you get d of y by x is equals to 2 integral x dx. Okay, now so integral d, all of you know integral dx is x, isn't it? Similarly integral d of y by x is going to be y by x is equals to 2. Now integral of x is, all of you know, it is x squared by 2. Now since you are done with the integration, you can put a constant of integration here. So 2 and 2 gets cancelled. So from here, y is going to be, do the cross multiplication, so you get x cube plus cx. So this is the general solution. Question is asking you to find the general solution of the given differential equation. So this gives you the general solution of this given differential equation. So you may pause the video and note down your solution. Let's move to next question. So next question, let me quickly simplify this. So you have to find what is dy by dx. So divide both side by x log x. Okay, so if you divide both side by x log x, so you get here dy by dx plus 1 by x log x into y. We have y here, isn't it? Is equals to, so you are going to get, see here, you have 2 log x by x, isn't it? So that's what is given to us. Now on top of that, if you divide with x log x, okay, so when you divide with x log x, so log x and log x get cancelled, so this gives you 2 by x square. Simple. So therefore we have p equals to, okay, so p is 1 by x log x, okay, and q, the value of q is going to be 2 by x square. Okay, so we got p and we got the value of q, and see, this contains x and this also contains x, so there is no y here, so we don't have any problem. So this is the first order differential linear equation. Okay, so we got the value p and q. Let's find the integrating factor now. Let's find the integrating factor. So this is equals to integral e to the power integral p dx. All of you know this. So this is equal to e to the power p. P is this much, remember? So integral dx by x log x, isn't it? Now, what kind of integral is this? This is integration using substitution. Okay, so let's do the substitution also at the same time. So let me do the substitution out here. Okay, so let log x equals to t. So from here you get, when you differentiate, you get dx by x is equals to dt. Okay, so that's why this can be written as e to the power, so dx by x can be written as dt, so it becomes dt by, you have log x which is t. Okay, so here this becomes e to the power log t to the base e. So like earlier one, since this one and this one they are matching, so this is going to be t. Okay, and all of you know the value of t is nothing but log x. Okay, so we have log x out here. So what is the integrating factor? Integrating factor is log x. Simple, right? So we got the integrating factor. Now let's multiply, all this is equation number 1. So multiplying 1 by the integrating factor, that is log x. Let's see what do we get. So we get, so when you multiply with log x, so you get log x dy by dx plus, when you multiply with log x and log x get cancelled, so you get 1 by x y, okay, is equals to, so here you are going to get 2 by x square log x in the right hand side. Okay, now one of the variable out here is log x, okay, and other variable is y, so you can write this as y into log x and find the derivative of this with respect to x. Now let's check whether this will be equals to this much or not. So keep log x as it is, differentiate y, you get dy by dx. Now keep y as it is, now differentiate log x, you get 1 by x. Okay, so this is equals to, so we have 2 by, we can say 2 log x by x square. Now bring dx out here. Okay, so bring dx out here, you get dy log x is equals to, so you are going to have here 2 log x by x square dx. Okay, so we have integrating both sides. Okay, so integrating both sides, so you get integral dy log x is equals to 2. Okay, so bring this x to the power minus 2 in the numerator. Okay, so you get this much out here. Simple. Now this is how much? This is y log x 2. Now this is in which form? This is in the form of integration by parts. So we have to apply integration by parts here. Okay, so always remember we have to differentiate log x. So we are going to integrate x to the power minus 2. Okay, so and using integration by parts, you are going to get this much. Okay, minus integral d by dx of log x integral, I don't have space here, so just wait a minute, let me write it here, minus integral d by dx of log x. Okay, so all of these will come within bracket, so integral x to the power minus 2 dx, outside also we'll put dx, so we have to close the bracket. Okay, so I don't have space here, you may pause the video and note down till here. Okay, then we get here, we have y log x is equals to, so we have 2 into, so how much is this? Now this is log x, this becomes x to the power minus 2 plus 1 divided by minus 2 plus 1. Okay, the integral, this integral becomes this much, so we have minus integral, now integral we have d by dx of log x is 1 by x into, so again integral x to the power minus 2 becomes x to the power minus 1 minus 2 plus 1 divided by minus 2 plus 1, and we have dx. Okay, so we'll close the bracket. So from here we have y log x is equals to, so 2 times, okay, so this is how much? This is x to the power, see it is, when you simplify this, this becomes minus 1 by x. Okay, so I can write this as minus log x by x. Okay, so similarly you get minus integral of, this is 1 by, see this is, this much is also minus 1 by x, so bring this minus outside, so it becomes plus, so it becomes dx by 1 by x into 1 by x is x square. So that's what we are going to have here. Okay, so let's simplify this also at the same time. Y log x, so 2 minus log x by x square plus this can be written as x to the power minus 2 dx, isn't it? X to the power minus 2 dx. Now again, you know x to the power minus 2 dx is how much? So y log x is equals to 2, so minus, we have log x by, this is just x, okay, I'm sorry, this is just x. Now again you know that this is minus 1 by x. Okay, so if you want to bring this something common out here, that can be done. So we have y log x minus 2 by x into log x plus 1 with constant of integration. Okay, so you can leave your answer to be this much if you want to. Okay, so this is the required general solution. Okay, so you may pause the video and note down your solution. Okay, so I'll give you one homework, kindly try it by yourself. Okay, so your homework is out here, so kindly try this. Okay, so I have not given you the answer, but try this and try to show me as early as possible. Okay, so with this we close for the day. Thank you very much.